Professor Cummings, and this is Lecture 2 in Module 4. The last lecture of this module, we looked over 5S, one of the more basic tools in Lean. And this one, we're going to be looking over another very basic Lean tool. So again, this module is Module 4 is specifically for Lean tools. So looking at different ways of eliminating waste, and we want to start with some of the most basic and most simple methods of actually looking at Lean tools. So in this one, we're looking at a pull system. So one of the more fundamental ways to set up a process. In this particular case, we're going to be looking at more of an industrial process, but this can be applied to, like I said, Lean Hospital. I keep wanting to emphasize that this isn't just a manufacturing tool. So let's get started looking at different scenarios. So the first thing I want you to do is just take a few minutes and look and tell me what is wrong with this particular picture. This was what you saw back in Module 1 when we were going over the lecture of what is Lean. So specifically, what is the issue here? If you had to try and diagnose this particular scene, this particular scenario, this gift playing over and over again, that well, I Love Lucy, what exactly is wrong with it? What could you nail down as some of the problems? Well, one of the first things you notice is Lucy and Ethel aren't really in control of this line. Everything coming towards them is coming at a outside pace. Is causing them to go faster than what they really wanted. They're clearly not being very careful. They're supposed to be wrapping candy one piece at a time, and instead they're losing all sorts of inventory. Of course, they're joking around and making it more comical for effect by eating candy, and in some of the scenes Lucy actually stuffs the candy into her clothes. But by and large, you can get the picture. The line is outpacing them. They're losing inventory, they're wasting a lot of motion, and they're overall putting a whole lot of non-value added time into this particular process, which is going to cost the customer money. And by definition, that is waste. So before I give you the official problem here, the official name, those are some of the things that you can see. So essentially the line is being driven at them as opposed to them dictating the pace of the line. So that leaves the workers in a very reactive mode as opposed to a proactive mode. Now, what would happen, again, just a hypothetical looking at this picture, if that was one variety of chocolate, say chocolate covered cherries, and they wanted to send down a different variety of chocolate? Well, one thing you could say is you're going to have all this inventory trapped into the line that they're going to have to address. Either it's going to go into inventory or it's going to have to be disposed of. So there's another problem. So again, you've got an issue with work in process. So again, you got a lot of prevalent waste. You got a lot of overproduction. You're going to have inevitable rework. Somehow they're going to have to make up for all the inventory that they're losing. You got a lot of wasted motion. Instead of a simple motion of wrapping the candy and sending it on its way, it's actually going through a whole lot of unnecessary gestures. Again, you're going to have to build up inventory because of all the work in process, just another form of inventory. So just to put it in, summarize in one sentence, the entire scene is totally chaotic. It's difficult to manage, and there's tons and tons of waste that they're going to have to address. So again, now let's keep in mind this entire scenario, because this isn't that different from most industrial settings or most work settings to begin with. This whole idea that work just keeps coming and it doesn't move forward to allow the operator to do a thorough job. So what could be done? Well, again, just laying it out more specifically, the work is actually being pushed to the next station. So wherever all this candy is coming from, it's being pushed to Lucy and Ethel. And it's being, or you could say more specifically, it's being pushed to Lucy over on the right, and she's actually letting it being pushed further onto Ethel, the little woman on the left. As one station completes work, it's actually signaled to move. So whatever's going on before, has its own independent signal in order to send this work on its way. So wherever the chocolate is dipped or whatever other process happens upstream, that's the only signal they're worried about. Just did this job get done, and can it be sent on its way? And again, like I said in the last slide, the inventory is being built up in the form of work in process. So this may not be the inventory of you getting parts from raw stock. This is another form of inventory. It's the work just sitting on the floor, a work in process, which is still a form of waste. One of the many forms of waste that we've looked at here. So again, when we think of the 7 forms of muda, and this is going to be an ongoing theme in this particular in module 4. These different systems, these different tools that we're looking at, will a lot of times address very specific forms of muda. And this, what we're going to be thinking about in this particular module, I still haven't said what the official title or official name of this is actually dealing with very specific types of muda. Motion, inventory, rework, and work in process. Now, if we were to look at an ideal, assembly process or industrial process, or just a flow of value being added to a product, there's certain things that would just stick out a lot more than that chaotic scene that we were just looking at here. In the ideal setting, there would be minimal inventory, minimal work in process. As you can see in this line, there's actually no work on the floor. The only work in process is actually what's in front of the operator. Each operator has something in front of them, and it gets passed on to the next particular station. The line is actually much more synchronized. So when somebody's working on something behind him, there's somebody working on something before him, and they're actually doing a very specific type of job. There's no wasted motion. Each person has very specific tasks, very specific work they're trying to do, and each one of their gestures, each one of their movements adds value to the end product. And this one is a little more difficult to see, but imagine if someone put the wrong bolts into place. In this type of setting, if somebody upstream 3 stations up had actually started putting the wrong parts into place, it would be very easy to find this problem and capture any of the defective components long before they become any more of an issue. So it minimizes the errors because they're actually identified and addressed early. So this entire system, because it's synchronized, because it's a very harmonious system, it's actually, you can't tell how it's being driven. You can't tell whether it's just you happen to have a series of the most well-coordinated people involved, but in actuality, a system like this would be called a pull system. So work is being released at the station that the work was completed, or it's being signaled the work is being completed, and it's staying put until the station downstream calls on the work. So an operator completes his job but doesn't release it, which allows for a much more thorough, much more complete, much more well-paced completion of work. A lot of waste is reduced through simply a pull system. The pull system does not force the work onto the next station. It's actually pulled by the station as the work is required. So let's look at this. So this is just a little graphic that I had found online of a push versus a pull system. And this of course is idealized. So you can see in the upper picture that you've got what happens when inventory or when work is actually pushed. As somebody finishes their job, you've got a perfect situation of Lucy and Ethel, with the candy. As the candy is dipped in chocolate and put on the conveyor, it's actually being pushed forward, and you end up in a situation like what you're seeing in this picture. It's coming to Lucy whether she's ready for it or not. Versus a pull system, where the work is not pulled until it's actually required, which creates a much more streamlined system. Much more streamlined, a lot less waste, a lot less built up work in process, a lot less likely to have an error getting lost inside of the system. So again, this push versus pull system, a pull system limits the work in process. It's based around a target lead time. So it is based around a lead time, and the decision of whether or not work moves or not is based on if it's suitable to release work versus whether the ability simply to receive the work, our ability to send it on its way. So it's based more around suitability in a push versus pull system. So this is Professor Cummings. This was a particularly short video, but I just wanted to make sure I got this particular tool laid out. Of course, your book should have several different types of tools, but this was one of the more fundamental tools. a push versus pull system in terms of addressing waste in Lean Six Sigma system. So again, this is lecture 2 in module 4, and thanks for watching.